All right. Assignment 1-5. This is the review assignment for the entire Unit 1 to go through. So it's the most important assignment you've done so far as it goes through all the content we've covered so far. Draw accurate graphs without using a calculator. And if you need a parent graph, so be it. So it's a graphing thing to begin with. Let's do it together. We're just going to sketch them. Do you know it's a line? Do you know it's a parabola? Whatever it is. And do you know how to graph it? So the first thing I kind of look at here when it's in this form is, can I easily find the intercepts? And I kind of can. If I make x 0 and solve for y, you can see that if I divide by 2, we have a y-intercept at 3. If I do the other way, it's a little trickier. So if I put in 0 for y and solve for x, when you divide, you can get the x-intercept too, and then you can use it. You could also say, there's different ways you could graph this, but I just wanted to show you this way. So you would go to 3, you would go to 1.5, and then you would connect. Notice this line has a negative slope. You would notice that if you solve for y, you would subtract 4x. It would be negative 4, right? That's the idea. All right, that's positive 3. Silly me. Okay, number 2. Can you graph negative x plus 4 divided by 2? This is also a line, even though you may not think it is. This is negative 1/2 x. 4 divided by 2 is 2. That's what you're graphing. Look complicated, but it's not. So again, the y and the x-axis, the y-intercepts at positive 2, and I'm going to go down 1 and to the right 2. And there's your graph. Number 3, y equals 1 over x plus 1. Definitely not a line. 1 over x means that we have some asymptotes we need to deal with. So we have an asymptote when x is 0. Now normally the other asymptote would also be at 0, but it's going up 1, so it'd be at positive 1. And then what does the curve look like? So if I wanted to, I could make it equal to 0, and I could find an intercept if that's helpful. So if I multiply by x, you can see the answer. We have an intercept at negative 1. So if you want one to curve through, but do you have the sense of the asymptotes in the curve? Number 4, the cube root of x minus 2. Cube root. So this means 2 to the right. I can do that. And then what does cube root look like? And then you have it. Number 5. Y equals the absolute value of x squared minus 2. So for this one, if I was going to graph, the vertex would be at 0 and negative 2. I'm going to do that in pencil because eventually I'm not going to have it. So, and the intercepts would actually be at positive and negative root 2. But it doesn't really bother me. I'm just going to curve it up from there. But recognize this part that I'm curving up, that part of the parabola is negative. So this part is positive. So notice I have the parabola that starts at negative 2. The absolute value says this part that's below is going to be reflected up. So we're going to go to positive 2 and reflect it up. And that's what the graph will look like with the absolute value sign. And then I can erase that if you like. But that's what it would look like. Number 6, x to the 2/3. That's a tricky one. So I always think that x to the 2/3 kind of looks like a seagull. Like when I was drawing it when I was little and I wanted to draw little birds over an ocean of some sort or a boat, that's what I would draw. So it's y equals x to the 2/3 subtract 1. So again, instead of at 0, 0, it starts at negative 1, and it kind of looks like a seagull. You know, when you drew a seagull, that's what it looks like, the x to the 2/3. I just kind of want you to get one key point and know what the sketch looks like. 7. y equals negative x squared equals 0. So I'm going to add x squared and then recognize it's just y equals x squared. So it starts at 0, 0. It's a parabola. Number 8. X equals y squared is not a function. It's a sideways parabola. And it folds to the right. If this was negative, it would fold to the left. But that's what it looks like, a sideways parabola. 9, y equals x cubed, subtract 1. So the subtract 1 means instead of 0, we go down 1. That's a point of inflection. So one side it folds up, and then the other side it folds down for a cube function. Number 9 is done. Number 10. Which of the following is not a function? Well, we talked about it. Number 8, right? Is not a function, right? Sideways, fails the vertical line test. Number 12. It says, without using a calculator, find the points of intersection. So we have y equals x plus 5. Y equals negative 2x plus 8. To find the points of intersection, we make them equal to each other and solve it. So I would add 2x and I would subtract 5 and then solve it. And then either one, if I plug it into the top, you can see that the y value is 6 and you have the point of intersection. Number 13. Again, for this one, we're going to eliminate a term by adding them together. So if I add these together, I get 2x squared. The y's eliminate, and that equals 18. Divide by 2. When you square root, the answer is both positive and negative. And then to find the y value, use either one to find the y value. And so if I use the bottom one, both positive and negative will give me the same answer. There's my bell I love. And then 3 squared is 9. And when you subtract 9, you can see the answer is 0. So the points of intersection are positive and negative 3 and 0. Number 14. In question number 14, here we go. It says, find f at x equals 1 minus x squared, and g at x is 2x plus 1. Find the following. And so can you add them together? That's easy enough. Just combine like terms. So we have negative x squared. We have 2x, and then 1 plus 1 is 2. So that's just combining like terms. That's number 14. That's A. For B, it says, can you do a composition, f composed by g at x? So when you do a composition, you're substituting one into the other. So f is 1 minus x squared. So take out the x and plug in what g is, which is 2x plus 1. You don't need to simplify it. Part C, g composed by f at 2. That's what that means. So you plug 2 into f and get an answer. So if I plug 2 into f and get an answer, 2 squared is 4. 1 take away 4 is negative 3. And then take that answer, negative 3, and plug it into g. So 2 times negative 3 is negative 6 plus 1, and you get your answer. Is that it for 14? Yep, 15. For number 15, find the zeros without a calculator. So x to the 4th minus 7x squared plus 12. What does it mean to find the zeros? You find the x-intercepts. You make it equal to 0 and solve this equation. We're going to solve it by factoring. So two numbers that multiply to 12 and add to negative 7 are negative 3 and negative 4. They multiply to 12 and add to negative 7. Take each factor equal to 0 and solve it. So I'm going to solve each of these. Add 3. When you square root, the answer could be positive or negative. Add 4. When you square root, the answer could be positive or negative. Those are your zeros. Positive and negative root 3 and positive and negative 2. Number 16, find the zeros again. So for 16, I have a piecewise, so I got to be careful. And I notice for the piecewise, in terms of that, so I'm going to make it equal to 0 and then look at the answer I'm given. And it's got to fit within the restriction. So if I took 2x minus 1 and made it equal to 0, you would add 1 and divide by 2. 1/2 is not less than 0. So this is not a good answer. Take the take the bottom piece, make it equal to 0. Add 4. When you square root, it's both positive and negative 2. But that's when it's greater than 0. So the only one that would work then is 2 is the only 0. So negative 2 you'd scratch out because it's not greater than or equal to 0. So 2 is the only 0 for number 16. Number 17. For number 17, it says find the inverse of this. Let's do that. So to find the inverse, we inverse x and y. And then we work at it. So this would be the cube root of x would be the inverse. Then you would add 1. And then finally you would cube root this. And then the symbol for inverse is that little negative 1. For 18 to 20, it says find the domain and range, intercepts, symmetry, and so on for 18 through 20. So for number 18, the absolute value of x squared subtract 4. So the first question is what's the domain and what's the range of something like this? So we did this one, right? X squared subtract, we did x squared subtract 2. So the graph of this, instead of going down 4 and then drawing it, it would be reflected up. So it would be at positive 4. The intercepts, positive 2 makes it 0. And negative 2 makes it 0. And so it's going to have this look to it because it's all positive. So this part that would be underneath has been reflected up. So domain and range. So first of all, it's all real numbers for the domain. The range, oops, that's the domain. The range goes from 0 to infinity. B, intercepts. So positive and negative 2. And we have another intercept up here at 4. C, the symmetry. So it has symmetry with which axes? So it has symmetry with the y-axis. We could also call it an even function. D, it's even. And then draw an accurate graph. We did that. All right, number 19. Y equals negative the square root of x plus 4. So this is a square root function. We have a reflection and it went 4 to the left. Make sure I have enough room here. 1, 2, 3, 4. Now what that negative does is instead of going up to the right, it goes down. Now we have an intercept here already. If I plug in 0 for x, the square root of 4 is 2. So at negative 2 is a intercept, and it curves this way because of that reflection for the square root. So if I go through the different answers, the domain goes from negative 4 to infinity, and the range goes from negative infinity up to 0, because that's the greatest value. B, what does B ask? Intercepts. We have one at negative 4, 0, and one at 0, negative 2. C, what symmetry is there? There's none. And D doesn't have any other. There's none. It's neither in terms of that. And then that's it, right? That's D and C. So number 20. It's good practice, isn't it? All right, the absolute value of x cubed subtract 2. And then how are we going to handle that? So negative 2 is still the negative 2 is still this. And when the absolute value bars are on the outside, kind of inside the function like that, so it would curve up to the right, has no effect. But when you put in a negative number here, it turns positive. And so this part that would normally be all negative then becomes positive. And this is the reflection that you see. So it kind of almost looks like a parabola now, because both the right and then reflected over because of those bars. So the domain is still all real numbers. And the range, the bottom value for the range is negative 2, and it goes up to infinity. For B, the intercepts, if I make it equal to 0, and solve it, add 2, it's the cube root of 2, both positive and negative. So if you cube root it, it's positive and negative, the cube root of 2. Those are intercepts. The y-intercept's at negative 2. This is symmetry with the y, so that means it's an even function, and you're good. All right, 21. In question number 21, you have a graph. I'm going to try to double screen this so that we can get both here at the same time. I can do it. So there's 21. I'm going to see if I can do this. Get my keyboard out of the way. See if I can make it work on the screen with both at the same time. There we are. So I'm taking that picture and I'm doing a couple things with it. So y equals 1/2 the absolute value of f at x. So what would the graph look like? So let's do that. So 1/2 means that all these become half the size. So I'm going to start with negative 3. That's going to be my 1. So negative 3 will become just half. Makes sense, there's half. Negative 2 is fine. At negative 1 it will be half. But because of the absolute value, it gets reflected up. So it's right there. So right now we have this part. So if you have a negative value, it gets reflected up. We have a parabola. Well, now it goes to 0. So we're going to connect that to 0. And then after 0, we have this parabola. It's just half the size, so I'm going to go to 1, 1. And then this part here at 1, negative 1 will be reflected up at 1, 3, negative 1 be reflected up to 3, positive 1, but it's half. So it's 3 and 1/2. All right, there's the first one. Number 22, when the absolute value bars are on the outside like that. See if I can get both in here again. Get my arrow out of there. These bars, you focus on the right side of the graph, so find the axes. So focus on the right side and then reflect it over. So here, just on the right side, 2 means all the x values have been halved. So instead of 1, it's a half and go up to 2. Just put these values down here. So a half and go up here. And that means this is 1 will be the intercepts here. So it goes 0 to 1, 1/2 at 2. Here, multiply it times 2, or half it. And again, it's going to be reflected up, like here, and then take that picture and reflect it over to the left. Right? Oh no. So when the bars are out like this for 22, sorry, the y values are become positive, and you're going to half the x's. So that's going to be negative a half and negative 1. But then it gets reflected up. So negative a half and positive 1 right there. The negative 2 becomes negative 1. And then the negative 3 would be negative 1.5. And positive 1 right there. I know, a little tricky, right? 23, doing it together. So all that means for this one is that, look at both, is that it's going to go 2 to the right and then 2 down. So it's the exact same picture, just 2 to the right and 2 down. There we go. So 2 to the right and 2 down. So we'll start at negative 1, negative 1. And then 2 to the right, here I'll take this point right here. So 2 to the right and 2 down would be at 1 and negative 3. Connect them. Here, this point would be 2 down and 2 to the right, so 2, negative 2. Then we have a parabola, the vertex, so 2 to the right and 2 down would be at 0. So 3, 0. And then it ends here. So this one, 2 to the right before negative 2. And then this ends here with this kind of square root reflection. And I see 1, oh here, move this 2 to the right. That'd be 5 and negative 3. And so you just move the whole picture down 2 to the right and down 2, and that's what it looks like. All right, 24. Turn the page. In 24 it says use a calculator. I have my calculator. It's powered up. And then do those things with the calculator. So let's just look at this. Y equals x over x squared subtract 4. Here we go. So press pause, get your calculator out, let's practice together. So I want to graph this, so press the toggle button and we're going to graph it. Press tab. If I need to change the window, I will. Go control divide for a fraction line, and then it's x, and then in the denominator is x squared subtract 4. Alright, so I'm going to change the window so we see it a little bit better. I'm just going to change it to 4 in all directions. Make it easier to see. Oops. So there's your picture, x over x squared minus 4. So this is draw an accurate graph. We're right there, right? We can do that. And so that's what the graph is going to look like. So notice positive 2 and negative 2 are asymptotes. Because the bottom is more powerful than the top, the other asymptote is at 0. And if I look off the graph, I can just sketch it as best I can. It goes 0, 0, it definitely goes through. So just looking off the graph in terms of what it looks like, right? and then answer some of the problems. So what's the domain and range? So when I look off the graph, I can see that x can't equal positive or negative 2. And then for the y can't equal 0, right? Oh no, it crosses over the y right here. So it's all numbers. So for the range, it's all good. It goes up forever and down forever. Part B, it says find the intercepts. We only have one intercept. It's at 0, 0. Part C, it says the symmetry. Yeah, it's odd. Is there symmetry with the origin? Sorry. So we say it's with the origin and that it's odd. So notice the top right, bottom left, top left, bottom right. That's with the origin. That means it's an odd function. And then draw a graph. We did. All right. 24 is done. 25. Let's use our calculator to graph this. What a great skill to have. Negative the square root of 5 minus 2x squared. Focus in. See if it'll focus for me. So we're going to type it in. So negative the square root of 5 minus 2x squared. Of course, you're going to go off focus, right? Now you're going to go on, maybe. All right, so that's what the graph looks like in terms of that. All right, I got a good idea there in terms of what the picture looks like. If I want to know off here what the intercepts are, I can do that. Go analyze, go to 0. I'm going to focus a little more in here to see if it helps. I know there's a little shine there. So I went menu and then analyze and then 0. Are you not going to focus in for me? No. Okay. Whatever. What can I do, right? So I'm going to move to the left of it and press enter, or press down on the pad. Move to the right of it, and it's symmetrical, so it's negative 1.581. And it goes to positive 1.581. So that's the domain. The range, I can just plug in 0 for x and know it's negative and the square root of 5 is left. So the range goes from a negative square root of 5 up to 0. B says find the intercepts. Those are the intercepts too. Positive and negative 1.581 and 0. And 0 and negative root 5. C says what's the symmetry like? So when I look at it, you can see there's symmetry over the y-axis, which means it's an even function. And we're good. Oh, we have to draw a graph of it. So 1.5, whatever, estimate that. Root 4 is negative is 4, so it's just a little bit more than negative 2. There it is. All right, 26. All right, y equals 3x squared minus 3x subtract 5. Let's see if we can graph that. Go press tab, move up, and then erase this, and then type it in. So 3x squared subtract 3x subtract 5. And then we need to change the window so we can see everything that we need to see. In particular, I need to see where the turning point is down there. So menu window, and it's the y minimum that I'm worried about. So I just need to see a bit lower of the graph. So if we could look at it like at negative, I don't know, 10. See, does that low? See, that's low enough. And I just need to find where that vertex is. With my calculator, I can go menu, I can go analyze and find the minimum. That's number 2. Move it to the left, press down, move it to the right and press down. And you can see we have a minimum there at 0.5 and negative 5.75. All right, let's see what we got here. So A asks for domain and range. So the domain is all real numbers. And then for the range, I needed that low number, that negative 5.75. To infinity. I can't even write negative 5.75 to infinity. The next thing was the intercepts. So the x-intercepts, menu, analyze, 0. So move to the left, move to the right, and it's negative 0.884. And then I need the other one to the right. So menu, analyze, 0. The one on the other side, press down and then move over it and press down again. Oops. Try it again, press down, upper bound. So I can see the number 1.884. The y-intercept, if I plug in 0 for x, is at negative 5. So it's 0 and negative 5. Part C, discuss the symmetry. So the symmetry here, there's none. And it's neither. There's no symmetry in either direction. 27. So for 27, it says solve this equation with a calculator. 3x squared minus 3x plus 1 is less than or equal to 0. So one way to solve this with a calculator, I'm going to press tab and I'm going to change this equation so it says 3x squared minus 3x plus 1. And I want you to notice the whole graph is above the axis. So when it says, where is it less than or equal to 0? Or did I type it in wrong? Oh, minus 3x. Tricky. Here's it, 3x squared minus 3x plus 1. Where is it less than or equal to 0? So, what am I not seeing here? So 3x cubed, that's what I'm not seeing. I knew I was missing something. 3x cubed minus 3x plus 3. I need to find the intercepts. And so it already tells me here. So one intercept is there. Isn't that nice? It already tells you what it is. And the other one is there. So let me just move them so you can see it better. Oh, that's not an intercept, but the other one is. Delete that one. All right, let's find the other one then. So menu, analyze, 0, move to the left of it, to the right of it. All right, so there we go, 0.742. Is there another one in there? Let me just zoom in here. All right, the window. Oh, there's another one. So let's go menu, analyze, 0, and then the one on the left. All right, so now there's 3 of them. Now the question is, where is it less than or equal to? So where is it below the axes? So if I look here, it's below from negative infinity up to negative 1.137. Where else is it below? And it's below between the 2 intercepts. There's a tiny bit below there, between 0.395 and 0.742. 28. For 28, it says solve this equation. Where is it greater than 2? We can use our calculator here too. I don't know if I even need the calculator. So for this one, we make it equal to 2. So subtract and divide. So at negative 1, and if I plug here for 2, find negative 1 and 2. Right there. You know the slope is 3, so we go up 3 and over 1. And so the question is, where is this line above 2? So from negative 1 on, it's above. So from negative 1 to infinity, it's above. Oh, is it the absolute value of that? Oh. So then it gets reflected up. So there's another spot right here that I need to know. So I need to make it equal to negative 2 and solve it. So that'd be negative 7 over 3. So from negative infinity to negative 7 over 3, and negative 1 to infinity. So it's above here and above there. That was a little tricky, but we figured it out. 29. Ah, my lights. So we have using our calculator, right? So I'm going to use find the value. So I'm still going to write it down. So x subtract y squared equals negative 7. 2x subtract 3y plus 12 equals 0. And it says find the points of intersection. So how we can do that with our calculator, because it's amazing. That's not where I go. Here. Press menu and algebra. And then number 7. And it's not linear, so solve the system of equations. That's 1. We have 2 equations, x and y, and then the first equation is x subtract y squared equals negative 7. and then move the cursor, and then it's 2x subtract 3y plus 12. Can I just type it in here? Equals 0. So x minus y squared equals -7. 2x subtract 3y plus 12. That's it. So it's at -0.675. And -0.5. Did it just say the x values? It says just the x values. So the x values are -6.75 and -3. That's it. Isn't it nice to have a nice calculator like that? Number 30. All right, we're not using our calculator anymore. So it says use a calculator for 24 through 29. So put away my calculator. Done. All right, g at x equals, we're on the home stretch here, trust me, x cubed subtract x. So for this one, if I want to know symmetry, I'm not going to plug in 1 because it'll give me a 0 on the bottom, so I'm going to plug in 2. So if I plug in 2, 2 cubed is 8, take away 2 is 6, and the absolute value of 6. And then I'm going to plug in -2. That gives me -2. -2 cubed is -8, subtract 2 is -10. I get 1/5. I don't get any symmetry. Let me just double check. What did I do wrong? Try again. So -2. Oh, a negative times a negative is +2. So it's -8 plus 2. Boo. So it's -2 over -6. Or absolute value of that. So it's positive. So anyways, long story short, these are odd because +2 gives you 1/3, -2 gives you -1/3. They give you an opposite answer. 31. The limit as x approaches, no, that's not 31. H at x equals x minus 1 over the absolute value of x cubed minus x. Okay. So again, I'm not going to use 1, so I'll use 2. 2 cubed is 8, take away 2. Let's make sure I don't make a mistake here. -2, that's -3, that's -8. A negative and a negative is +2, so it's -8 plus 2. This one I'm pretty sure they're not matching at all, so there's no symmetry. Neither. All right, 32. The limit as x approaches -2 of 3x subtract 3. This is a continuous function. Just plug it in. 3 times -2 is -6. Take away 3. 33. That's a greatest integer function. It's a step function. I usually draw it this way. A double bracket. It gets drawn in different ways. Now, for an integer, there's a jump there, but I need to know what the jump is. And so if you plug in 2 for x, 2 divided by 2 is 1, and 1 take away 4 is -1. Now, from the left, so again, 2 divided by 2 is 1, and 1 take away 4 is -3. Now, on the left, it jumps down. So this answer is actually going to be -4 because it jumps down at that point from the left. If it said plus, it is what it says. If it says minus, it's the one before it on the number line. Let's try it again. 34. You get a second chance. So what's the limit as x approaches 2 of this greatest integer function? Well, if this gives you an integer answer, there's a jump. So 2 divided by 2 take away 4. That's an integer. So this limit doesn't exist because there's a jump. 35. Ooh, same question. Nope. +3. So the limit as x approaches 3 from the right. So for this one, it actually doesn't give you an integer answer. So 3 divided by 2 is 1.5. Take away 4. What is that? -2.5? So 1.5 take away 4 is negative 2.5, and the greatest integer less than or equal to it is negative from the right. But it's right in the middle of the step. Can I not know what this is? Right? And what's the greatest integer less than or equal to that? So it goes to negative 3. Oh, I have to think through that. 36. Sometimes these step functions give me a little twirly in the head. 36, you got to look off a graph. So this one I'm going to write down first, and then we'll come back and look at the graph. So there that is. I think this is the most efficient for me to write it down first. All right, so let's start with each one here. We're almost there. So for 36, the limit as x approaches 2. And so here I find 2, and I realize there's a jump at 2, so the limit doesn't exist. 37, what's the function value at 2? So at 2, I go to the point, and the y value is 2. 38, the limit as x approaches 2 from the left. So find 2, and then from the left, the y value is negative 2. 39, the limit as x approaches 1. So find where 1 is, and from the left and right, they agree. The y value is 0 there. Number 40, the limit as x approaches 0. So it's continuous there, so the y value there is 2. And then 41 says the removable means the limit exists at a discontinuity. So at x equals 1, the limit exists. That is removable. And then at 2, there's a jump. So it's non-removable, that discontinuity, because the limit doesn't exist at a jump. Number 43. This is it, 43 to 48. So I'm going to write down the 3 pieces. X minus 1, x squared minus 1, and 4. So let's go through the steps. First of all, for 43, it says to sketch it. So let's do it. So plug 0 in for x, and you get negative 1. So I'm going to start at 0, negative 1. That'd be right here. And then the slope is positive 1 going to the left. So there's the line there. That's up 1 and over 1. And then I plug in 0 here, and I get 0, negative 1. That's helpful. Plug 2 in. 4 take away 1 is 3. So go to 2, 3. It's going to be a hole there. It might be covered up when I plug it in. No, it won't. So it's a hole there. This is a parabola folding up here. And then 2 on, the answer is 4. So there's your picture. 44 asks for the limit as x approaches 0. So when I look at 0, it's continuous here. The y value there is negative 1. 45 says what's the limit as x approaches 2? So at 2, there's a little jump there, so a limit doesn't exist at the jump. 46, the limit as x approaches 2 from the left. So here's 2. From the left, the y value is 3. And then it asks from the right, it asks for the limit as x approaches 1 of g at x. So 1 is in the middle of this continuity. 1 belongs to the middle. So plug 1 in here, and you get the answer 0. And then 48, last one. List all the discontinuities. So there's only one discontinuity, and that's when x equals 2. And it's non-removable because the limit doesn't exist there. So at x equals 2, there's a discontinuity there. There's a jump, so it is non-removable. And that's it. Mr. G Math over and out. I'm proud of you for doing your work. Until next time.